So welcome to our session. We obviously it's a Saturday and we still expect people to keep turning in, but we will go on. My name is Nikhil. So I head up the R&D team at the Assembly, and you've met many of the team before as well. We are, right now doing all our workshops virtually on Zoom. Some of them are on YouTube live, and you can definitely check out our site to catch up with all of the other sessions. So today's session, as I mentioned, if you were here for the last session where we spoke about setting up a data flow, we did a data flow from the edge, which is my laptop in this case, but it could have been a Raspberry Pi, it could have been anything, from the edge over to over to the cloud server that we were using. We're all going to be using a PTC cloud server, so each of us will have a separate server. It's very easy to set up. PTC Cloud provisions it online. The trial version is like last 30 days, so we can use that. If you were here for the last session, that's good because there are some parts that will overlap, but mostly, I mean, if you weren't, don't worry about it. We are going to go in a completely different direction, and anything that is there to catch up, we will catch up. I'll show you how to do that. We'll definitely take the time to do that. Let me just start sharing my screen again. Just a quick bit about the Assembly. You saw the intro already, but a little bit more about that. We've been around since 2014, and we're based out of In5, which is in Dubai Knowledge Village. Before we started doing our workshops only virtually, thanks to the current crisis going on, we did in-person workshops, and people actually came to the space. We have a pretty large space. We have our lab is there as well as In5, and a lot of people interacted there. We've done almost 300 free workshops, counting everything together. I'd say about 90% of them have been in person. Assembly hack workshops involve hardware also, so embedded systems, IoT, and when you come for workshops like those, we provide the hardware for you. So we have, if you needed a Raspberry Pi or you needed circuits and things like that, we would provide all the material, and you could definitely get involved with that. Assembly code workshops are a bit different. We don't have any hardware, but we do involve a system, so you just need to bring your laptop along. Obviously, hack workshops would also require your laptop because there is code in embedded systems as well. Data science is our most recent stream, and data science is something that we've just been doing over the last year, and this workshop will definitely qualify under data science. The last one might have qualified as assembly hack, but this one is very much data science, although we are going to, of course, tie in with the IoT pipeline. Our audience is from all over. We have students, professionals, entrepreneurs. In5, as I mentioned, is the entrepreneurship hub in Dubai Internet City. And we focus on practical applications. So we like to get down and dirty with the stuff and build things hands-on. So there are practical applications. You would have signed up for our forum. You would have, you will be able to access all our previous resources. You can also RSVP on there, so we have many different forums that you can access and RSVP on things. Make Smart Things is our social media handle on Facebook, Instagram, Twitter, and you can find us on LinkedIn and YouTube as well. These videos are going to be on YouTube also, and of course, from YouTube onto our site. So that's just a little bit about the Assembly in case it's the first time that you've come here. Let's have a look at, let's take over. Let's do a little bit of continuity from the last session. Okay. Before I get into this, what I want to do is just make sure that everyone is set up. So now in the lead up to this workshop, we did tell everyone to sign up on PTC Cloud for the free trial download. I use the term download loosely here because you don't really need to download here. It's just a free trial. This is something that PTC has launched very recently where they give access to a free hosted server. You can, if you want to get a local install and you want to install the full version, it's a 3-month trial installation, and you can do that. But you would need to do, there's a separate install for ThingWorx Foundation and ThingWorx Analytics, which we're going to use both. You don't need Kepware. But it's a little tricky, so we wouldn't recommend doing that for this session. So once you are logged in, just go to free trials, and that will bring you back to here, and just click on access the free 30-day hosted trial. Now I've already done that. So I've got my server already set up. You would probably have a message saying here that, enable your server. And what's key here is you need to look at 2 things. You need to look at the host name, which is going to be your internet location for accessing the site, and you need to copy your password. Your username will be administrator, and your password is whatever's here. So you just copy it to clipboard. You're going to need that. I've saved mine, so it in my browser already knows that, but you would have to enter it manually, and it would probably be advisable to save it. Now, the difference between your server and my server would probably be just this little ID in front, where it says pp-20121413222yn. Mine will be different from what you have, and each user gets a different ID for that. So I'm just going to go ahead and start it. It will be a little bit of a process, and that's why I'm doing this first before I go back and show you anything else. The page will automatically refresh once it starts. So you need to wait for the server status to change here. Yeah, so it is launched, but if it is started rather, but if I click launch here right now, it'll open up another window, but it still can refuse my connection for now. So you need to just be a bit patient with that, which is why I did it at the start. I'm just going to close up this other window. Okay, so don't worry about this. When you see error connection refused, it just means that it's in the process. So you just need to give it some time. In the meantime, what I'd like you to do is also go into GitHub. Okay, so the assembly GitHub, you can navigate from there. You can go to github.com/the-assembly, and you can easily get things from there. So these are the different files you need for our session today. So the data directory is actually going to, if you want to just download the whole thing into a directory, you just click on here and do download zip. And what will happen is that you will get the data is the actual data we're going to use to build our model. EMS is something, if you were here for the last session, you would have kept it. You don't need this necessarily. It's optional, and we'll only use it later. But if you want to see how to send out data from the edge onto the cloud, this will help us do that. And apart from that, I've also got we only need one thing on our cloud instance, which is the edge thing. And in case you weren't here last week and you need to access that again, you can just take this. I'll show you how to import it later, but for the time being, just do that. So let's have a look at our use case again. Now, this is something that we did last time, and we had put up, we had set up the data flow so that our engine was our edge thing. So it was a thing that was sending us data from the edge. And the engine was sending a few different types of data to us onto the cloud. It was sending us data from 2 vibration sensors, which had 5 frequency bands each. So we're talking about 10 readings, 10 vibration readings that were coming in, and we had simulated the values. And we will use some of the simulated data later, but you'll see how to do that. And it also sent a flag which indicated a catastrophic failure is taking place. So it was just true or false. And that's oversimplifying things, but it could have been another thing. It could have been a condition that the engine is known for, like say the greases, it could have been reading low grease, for example, or it could have had some sensor that flagged that. But for our purpose, we'll just say that it is just flagging a failure. Now, our goal today is to find a correlation between the 10 vibration readings that we're getting and the catastrophic failure value. And by looking at the data, and if we are able to predict what the failure, what vibration readings cause the failure to some degree, I mean, we will look at all the modalities for that, then we will be able to say in advance that, okay, our engine is about to fail, which is a very powerful thing. I mean, if you are somebody who sells these engines, you could have a subscription service for the user where they could know that something wrong is about to happen. And we do that using, of course, the vibration sensor. So this is our scenario. Now let's have a little bit look more about what our plan is for today. First, we're going to build a model. How do we do that? We use ThingWorx Foundation. ThingWorx Foundation is what we've already used before. Connected devices send data to the platform. We'll extract the data in a CSV format, which we did last time. We'll start from the CSV, and we'll build a predictive analytics model using ThingWorx Analytics Builder. We'll publish the model to ThingWorx Analytics Manager. So those are 2 separate parts that you want to see. They're both under Analytics Server. So ThingWorx Analytics Builder is where we build the model from the data, and Analytics Manager is what operationalizes it. So when we want to operationalize the model, what we'll do is the connected devices from the edge will send data to the cloud. The cloud will send the data to Analytics Manager, and then based on that, we will predict results dynamically in real time. So that will be our plan. This is a little bit about machine learning in ThingWorx. Don't worry about it too much. What you need to see is like when we build the model, the important thing is the historical data. So you want to remember this 80-20 split. So we'll use 80% of the data, and this is only a default. You can set this, you can change this around accordingly. We'll use 80% to train the data and to build our model, and then we'll use the remaining 20%, which is randomly sampled, to build our model, to test our model and see how, what kind of precision it's giving and whether it's proper for using. And once we've done that, then we will bring it into production. Okay, and let's go back to our server now. That's the more important thing. Okay, so coming back to this, you should have synced up by now with all the GitHub. Hopefully you would have got data, which is just, there are just 3 files there. 2 of them are big. That's the main data. You have to get data. EMS, it's optional. EMS is the full folder. I just exported it from last time, what we used for setting up our edge connection. And it's good if you have it. If you don't have it, we don't follow along. It's not the end of the world. So don't worry about it too much. And of course, you need this things.edge, thing.xml. I've given a few things. If you are interested in the EMS and you want to like get some more, I've given some instructions for how you can start up the EMS. I will cover that later when we go into it. But for now, let me just close this. Let's go back to our session. Let's reload and see if our portal has started up. So each of us will have a different portal, obviously. Like I said, you can see the title there, pp-2012141322 is mine, but you will have a different value for that. And that's a very important thing to remember. Okay, so this is just the default. This is the composer, which we've already used in the past to build our, our data flow from the edge over to Thing. We're going to use the same analytics. So this is ThingWorx Foundation, which has all the different things and thing templates and projects and data shapes and everything that we've done in the past. But now we're going to use a new model, which is automatically activated as an extension. You can see it in the menu here. You can see analytics down there. So just click on analytics and you'll get 2 menus there, analytics builder and analytics manager. So we're going to start straight away with, first of all, getting our data in. Okay, and we're going to try 2 data sets today. One is going to be the test data, which we have been using from, from the edge. So under Analytics Builder, we need to add the data in. And I'm just going to show you the data first. I'm just opening it up in the background. So let's see how it shows up. Now, what you want to do is you want to go and you want to create a new data set. And the data set name, I'm going to just call it something like, since we're using simulated data, I'm just going to call it simulated data set. I have to choose the file, the CSV, and while the data is importing, we'll go over the actual data. And I need to go to see, I've already synced up the GitHub here. So you can go to GitHub, go to Predictive IoT, go to data. I need to actually select test CSV file.csv. Okay. So that is that we'll open that up and see that this is the data as has been simulated in code from the edge. And then we're going to go to, we have to give it, we give the metadata, and it's actually the same for whatever data. This just defines like it's a JSON file which has some info. So you just select that. And then you just hit submit. So while it's doing this, I'm just going to open up the file. Let me see. I might have to share it again with you. Let me just show you. I have the EMS code somewhere. I'm just going to, we had set up an edge device which showed all this data. So I'm just going to go to custom. So this is the function we used to generate our data. And the function, what we'll show you is very similar. So if you can understand this, this just randomizes a number between 1 and 10. And if the number is less than 6, so if it's, if the value is less than 5, so about half the time, it'll indicate a failure value is 0. And the other half, it'll indicate a failure value is 1. So this is obviously not going to happen half the time exactly. It's just going to be randomized, but you'd expect it to happen half the time. When the value is 0, we've added very little noise to our data. We've given it a fixed value. We've said, so S1 FB1 is our first vibration reading. S1 FB2 is the second vibration, et cetera, et cetera. So it's sensor 1 frequency bands. S2 underscore FB1, S2 underscore FB2 is the second sensor. And you can see we've seeded it with a value. So whenever the failure value is 0, so not a failure, it's 161 plus math.random. This is adding a very small increase to it. So it would be 161. So it's a very little bit of noise. So our data will almost always, and we'll see that in the thing. However, when failure value is there, the values are quite different. But you'll notice in the case of the final sensor value, and this is important, S2 underscore FP5, it's the same, 190 plus math random and 190 plus math random. Now that's going to be a little important later, and you'll see why. So this is our data that has been generated by that function, by running it, in a time series. And you can see very little noise has been added. So when there's a failure, S1 FP1 will be 90 plus a little bit of value, but that's just a little bit of noise. So you can tell the same from all this. So it's very ordered data. And so it's not really good data because it's too ordered. And you'll see that when we run our file, what result it has there. So you can see a few variations that we have and a little bit there. But by and large, if you were only to round it up, you would get the same data. So it's quite static. So let's go back and see our data. Okay, so we've copied the data as we've looked at that. And now our next job is to analyze this data. So we go over to signals. Okay, so signals actually tell us tell us which field out of all the fields that we are analyzing actually correlates the most. So I'm just going to create a new signal using that data set. I'm just going to call it, simulated underscore signals. The data set I need to select, I only have one at this point, and it automatically picks my goal data set, which is failure. So everything is being mapped to predict the goal, which is the failure. And then I just hit submit. This will be done much quicker. You'll see that. Hopefully my internet will hold up. So signals tell us which of the individual fields. Remember, we have 10 fields here. Okay, it's completed. Which of the individual fields actually correspond to our, are relevant. So if you see, there's actually a perfect correlation because of the way our data has been generated. So S1 FP1, S1 all the way up to S1 S2 FP4, all of them are perfectly correlated, which means you can take any of these fields and you can perfectly predict the result just on that field. So this is not really how it would work in real time, but it's a good idea about how it works. But you'll see S2 FP5, which is the same value for whether it's a failure or not a failure. It's always 190 point something, whether it's a failure or not a failure. It is not, it has been rejected because it is not influential at all. So it's got a 0 score. So this is really important. And you can see that it'll give, if you click on any of these, it'll give you like a description of, what it does with the data. So here you can see, like, you can get all sorts of stats here. It tells you the records. We have 30,000 records here. So there's a lot here, and it tells you why it is statistically no use. The same with any of the other sensors. So it tells you that when it's from 170 to 170.9998474, which is our noise, it ignores the noise. You get the goal of 1. It's perfectly predicted. And whenever it's 160 to 160, it's 0. So it's already predicted this. Now, the next thing we want to look at, because again, with the same data set, let's do profiles. Profiles, like signals, work on individual fields. Profiles give you things for combinations of data, combinations of field. So let's see what it does for us. So we'll just say this is simulated underscore, what was it? It's profiles, right? Same process. You do that, and then we just say submit. You can ignore the rest of you can definitely play around with the other settings, but you can just leave them default for now. Now, this is interesting because normally profiles give you a selection of different combinations. Because our data is an exact fit, it's only shown you one field. So it's picked S1 FP2 because possibly S1 FP2 had had the least amount of noise by some case of luck. But because it only varies from 170 to 171.3 and the goal is there, it says the profiles tell us that the only profile you need is one field, If you only had one field, it would predict our result 100% of the time. So this is too perfect, and this shows the flaw in our data. And this is just to give you an idea about signals and profiles. Now again, we'll also go on to building a model, right? So now let's go to actually building our model and see how it responds to this data, which we know isn't very good because it's too perfect. But let's see how it works with that. Simple process again. Just say new. You go to the data selection. You just do simulated data set. Now, there are different things you can do here. If you want to look at under the hood, if you look at the advanced model configuration, so validation holdout, remember I told you that it will use 80% to train and 20% to validate. This is where you set it. You can also exclude fields. You can do all sorts of things. We're going to generate a confusion matrix, and I'll explain to you what a confusion matrix is in a bit, but you can set weights here. You can set, so the different techniques that it does has to build the model, that you can add different layers. So you can add a decision tree, a gradient boost, linear regression. Those are the normal ones. So, this is just the default. We're not going, that would take a whole other workshop. So let's not worry about that too much. You can add a neural network there. So learners are how you can go that. I've sent you a link which will show you a little bit more in the chat about how you can work with analytics. So if you are keen on looking under the hood, you can definitely do that. But for now, we'll just use the default. So we've got this. We have to give a model name, of course. That's why it's not simulated underscore model. And say, we've got this, and I just hit submit. So this could take about 60 seconds. So, we'll wait for that. What we'll do in the meanwhile is I've actually got, like I told you, this data set. I'm going to import, like I had some more data that I could install. You can see that it's the vibration data set. So I'm going to go back while my model is being generated. I'm going to get my other which is more realistic data that has been got from there. So I'm going to call it vibration underscore data set. It's again also in GitHub. So you just take vibration data.csv. You can use the same metadata file that we used for the thing because the fields are exactly the same. And I'm just going to hit submit so that it imports this while. So this is nice. You can see that I can multitask also here, while we're doing different tasks. So let's go back to my model. So you can see here now the model has been created. Let's open it up. Okay, so let's have a look at the analytics. Let's have a look at the model that we've created here. Now, this is an ROC curve, and I sent you a link if you want to see what an ROC curve is. There are two hints of elements here that you want to look at. So the confusion matrix is really important. The confusion matrix, now, before we do anything with the confusion matrix, I need to explain to you what these values mean. Okay, so this has taken our results. This has validated 20% of our data, which has been randomly picked. So if you take the same data set and train it again and validate again, you might get different results. You probably won't in this case because the data is so predictable, but it randomly picks based on its own model, and it does a few different things there. So this is what a confusion matrix tells us, the validation settings. So on the left-hand side are the predicted results, which our model has run through. And on the bottom are the actual results which it has from there. Now, most of you would have heard the term false positive, true positive. These days with COVID, of course, when we have tests, we say false positives and we say true positives. Now, to explain to you what this is, a true positive is when, in terms of a disease, let's say if you actually have a disease and your prediction is that your model predicts that you do have the disease, that's a true positive. If you don't have the disease and your model predicts that you have the disease, that's a false positive. Similarly, if you don't have the disease and the model predicts that you don't have the disease, that's a true negative because it's true to it. And if you don't have the disease, if you do have the disease and the model says you don't have it, that's a false negative. Okay, so those are the four quadrants that we have here. And if you look at our data, so out of our training data set, 50% of it is either a true positive or a true negative. So which means 100% of the predictions have come true correctly. So our data is perfect. This could be good for this, but it's too perfect for our requirements. So if you look at the false percent, we have no false positives, we have no false negatives. So our prediction matrix has been perfect. Now, if we go back to the ROC, now the ROC is usually a curve, and it is good when it's towards the top and the left. What an ROC does is it predicts based on different thresholds. So remember, we're saying a threshold of 50%. Score of 50% would give you a total. A score of 50% is our threshold usually. So if our score is more than 0.5, we say it is true, and if it's less than 0.5, it's false. But what an ROC does is it creates a confusion matrix for different thresholds. So this confusion matrix just is doing that. It's assuming 50% is the threshold, but an ROC goes a bit further, and it creates confusion matrices for many different thresholds, and then maps out the true positive rate, which is the same as our, it's called sensitivity also. So sensitivity or recall is our true positive rate, which is the percentage of true positives out of all real positives, right? So say in our case, in the confusion matrix, this is our true positive, this is a number of true positive. So 3290 divided by 3290 plus 0 plus 3, so it's perfect, it's 1. So 1 is the perfect rate here. And you can see that that's what it's like. It gives an ROC which is all along here because there is no variance in the data. Okay, so you are getting a perfect ROC, and that is why our recall is set to 1, because 100% of our records are true positives. Specificity checks how many false positives are there. So it means, like in this case, it's 1 minus that. So our specificity is also 1 because it's perfectly correlated, right? So 100% of the records of false positives, 100% are not false positives. So these few things, you can read up a little bit more on them. So specificity is the percentage of true negatives out of all real negatives. So the number of, if we said, like, in this case, if you go back here, the confusion matrix, accuracy is the top quadrant divided by these total number of records gives you the specificity, and the bottom right quadrant divided by the total number of records gives you the specificity. Sorry, the first one gives you the recall or sensitivity. This gives you the specificity. The ROC, this reading is actually a measurement of the area under this curve, and it's 100%, because our curve actually goes up. You can't even see the points. They're all along the corner and they're down here. So you can see this thing. So this is something more to do with that. Precision is another setting which checks the number, which actually looks across here. So if you look at the confusion matrix, precision checks 3290 divided by 3290 plus 0. You can see this explanation. I've shared a YouTube video which has more details on this, but this will make more sense once we have some more real world data on that. Okay, so that's fine. So we understand that it takes 80% of the data in this case, which is why you can see, if you look at the training metrics here, that's about, so we're talking about 13,000 records and 13,000 records here. So about 26,000 records, which is 80% of the data out of our 30,000 records. So it has been trained on that, and our model has been created. And then to validate, it has been validated over the rest of the data. So which is the remaining 3290 plus 3316 records. So the remaining 6,000 records is our 20% of data, which is matched, which is very standard practice. So it's done that. Now let's go back to our data. Let's look at our real world data set. So this is the data that we are going to upload now. Okay. And if you look at it, it's a lot more realistic. There is a range, and you can see all the data on there, that it goes from, it's not like the previous data where we had a very limited range. You can see values like 193, and you can look at the whole data set. So you can have a look at the data, and you can see how, false is, how it correlates on that. So I'm going to close this because I don't want to take up too much memory. And I'm just going to go back to my analytics. So my vibration data set, which is the more realistic one, has been properly got there. And we've got about 30,000 records right now. So the same process. Let's go back. Let's create a new signal. Let's see what it shows us. So I'm just going to create a signal. I'm going to call it vibration underscore signal. And we'll use vibration dataset. Again, it takes failure automatically. I'm going to submit. And while it's running, it's going to keep that. It should be done any second now. Okay, there, it's completed. Now it shows you the results. Now this you can see, like before when we had that, it was all 1, 1, 1 for each field and 0 for S2, FB5. But in this case, there's more. It gives you more rating. If you look at it, if you select each of them, and it seems that from our data set here, that all the sensors, all the readings are coming from sensor 1. So the more accurate signals are coming from S1. So it raises the question, do we even need sensor 2? Because sensor 2 is not really showing. I mean, sensor 2, okay, S2, FB1, that's frequency band 1 and frequency band 4 in S2 are pretty okay. But the others are pretty irrelevant. They're 0.04, 0.04. So we can pretty much ignore all of them. So this is very important. This tells us from our signals. And if you look at it, like it tells you the number of records that it's, the goals, the values that it's saying, and it's giving you a score for the values. So remember, we have our values, like our data sets it to 1 and 0, but the prediction is always between 0 and 1. So it goes 0.9 to 1, so whenever values are between 216 and 235, the average goal is 0.92. It's a pretty good fit compared to that because it's telling us that. So it's telling us that S1, FP1 is very prominent. S1, FP5 and FP2 and FP4 and FP3 are also quite good. But what we want to do now is let's look at the profile. So let's see what combinations we get. Now, if we go to this, let's add a new profile. For vibration underscore profile, same data set, and we just hit submit. So this is going to analyze and give us combinations. While signals gives us the individual ones, this gives us the combinations. Okay. So if we look at the scores and we look at them down there, it actually gives us many profiles. It gives us 7 profiles. But we want to look at the number of records that it uses to see if these profiles are this thing. So this one uses 19.77, 7.44, which is okay, 7.69. But the last few are pretty useless because they use like 0.58% record. So we can just ignore these completely because they don't use enough data. So we can just ignore the last couple of profiles. Even these are not great, 5.8%, 1.3%, 7.69. The most significant profiles are the first ones. And it does tell us that if you use S1 FP2, if you use S2 FP1, S1 FP3, and S2 FP2, if you combine those, that gives you a pretty decent profile. Like it predicts the correct values in this many percentage of records. But at the same time, like our profiles are good, but our signals were much better. So what I'm going to do here is we'll run the model anyhow. Let's run the model so that we can see what it looks like. So this is using 100%. You can set filters also so that it could use fewer records. You don't want to, when you are like sanitizing the data set and you want to edit exactly what's happening in there, you can definitely do a few things there. So remember, this is real world data. So we're going to get a much nicer ROC and confusion matrix here. It won't be 100% in one side. Okay, so we've completed the full thing here. Let's have a look at our model. So here, this is a more normal ROC, but it's still a good one. So if you look at, just a quick reminder, if you run it, you might get slightly different results, but you'll still get the same broad thing, because the reason for the difference is because you might use, it might use different training data. So it should be roughly the same, but you can see this is a good ROC, which shows a good result because it is high and to the left. So, if it was somewhere, if you think of an imaginary line joining this 0, 0, and 1, 1, that is the thing. So if it was coming below 0, 0, and 1, 1, that's a bad ROC. The amount of space that it covers, as opposed to the amount of space it doesn't cover before, the area under the curve, The higher that is, that value is better. So you can see here about 92% is under the curve, which is a very good ROC. Specificity, again, I told you, is the number of false negatives, the percentage the percentage of true negatives out of overall negatives. And recall is the percentage of true positives. So we're going to look at the confusion matrix again. And you can see that the false positives, this is what is used to calculate the specificity. So it would take, 3669 divided by 365 plus 3669, which is roughly about 4,000, right? So that gives you a 90% specificity rate. Similarly, your accuracy rate, if you take 1564 divided by 1564 plus 504, which is about 2000, would give you about this 75%. That's not great. And maybe if we ran a different model, it might work better, but it's still good enough for our purposes. So we'll take that into thing. The precision is pretty good. 1564 divided by this plus this. So it's about 81% here. So these tell you about the prediction, the rate of your models. But you'll notice one thing, like we said in the previous thing, that our model didn't really use, like when we looked at our signals over there did not really use, our signals did not really say that, suggest that our second sensor, so for half of our readings are really that relevant. It said most of the thing is coming from the first sensor. So what we're going to do is we're going to take a business decision to exclude the second sensor. And this is really important because remember, all this data is coming, that's that much, double the bandwidth, double the processing, double the analysis. And when you multiply it by a number of things, that's a lot worse. So let's go back. Let's go back to our model and let's create a new model here. And we're going to call it vibration_model with one sensor. Okay, we'll take the same data set, the same value, but I'm going to create a filter here. Okay, I'm going to exclude fields using this. So this lists all the fields that I have in the thing. I'm going to select field S2 to S. These are all for my second sensor, and I'm going to just add them as my fields to exclude. So now I select. Now when I calculate the models, they will only take the first 5 fields. So S1, FB1 to S1, FB5. So let's submit. Okay. So our vibration model has been set up here, and let's have a look at what it looks like. Now, if you look at our ROC is still pretty similar. Slightly less in the recall. The specificity is slightly less, but it's still covering a good amount of area. And if you look at the confusion matrix, the number of records is still okay. It's still got a decent thing. The negatives, it's a lot better because we've got a lot more negative records in our data, but it's still a good ROC that covers about 90%. So this means our model, though we've excluded 5 fields there, it's still doing pretty well. So we're going to make that decision that we're going to exclude the second sensor already, and we've halved the number of sensors just by analyzing that. So this is our model. We've created our model, we built it. Now our next job is to operationalize it so that it can work on live data. So what I'm going to do is first, I'm going to go to analytics providers. Okay. An analysis provider is just a mathematical engine that's used here in the analytics manager to provide our model. So it's just a pretty, so I'm just going to call it anything. I'll just say something like, vibration and AP. You don't need to enter anything. It has to derive again. So I'm just going to take it from, you just need to enter an analysis servers. Yeah, this is the one. This is the analytics server connector. You can create and code different ones of these. ThingWorx is quite extensible, so it's not too difficult to do. And I just say save. Okay, it just gives me a small thing there, and my analysis provider is there. I'm going to go back to my model, which I was happy with right now. Right now, I've trained it up and seen everything. I need to publish the model. So I'm going to select this one, vibration model with one sensor, and I'm going to publish it. Okay. Publish means it is available to Analytics Manager. Until we do that, it is not possible. Once it's done that, it's available in the server to everything. So this is our model. It creates a data shape and it gives you a few different things you can see. You can analyze all this. So it says this is what our fields are. So this is done. So I'm just going to close this. So our data model is published. Let's go back. Now let's see under Analytics Manager. Okay, so now that I've published, you can see it here. So the other ones which I haven't published aren't there, obviously, but here it's there. I need to select this and I need to click enable. So enable is set to true. So we're done with that. Okay. Now that my analysis has been created, I need to connect it to my ThingWorx thing. Now this is where we go back to our source. Like I'm going to go back and browse. I'm going to go back into ThingWorx Foundation. And I'm going to look at the thing that I created last time called Edge Thing. This was, if you remember, this was the physical representation. It's not connected because I don't have the EMS server connected, but it is present on the cloud. So it is not getting data from the edge, but it is on there, even if it's disconnected. Now I need to make a few modifications to this before I can incorporate my property model. Now here's a quick, so remember the file that I've given you, an XML file in GitHub. If you don't have Edge Thing and you want to import that, all you do is come to the import wizard. This is the import option. If you've already got an Edge Thing and you import something else called Edge Thing, it will just overwrite. So it's very dangerous. So if you've already got an Edge Thing from last week, don't do this. Or you go to the XML file, you find Edge Thing. You can just go here. So this is the XML file. If you search for Edge Thing here, so that's the name. You could just change the name here to Edge Thing 2 if you want to import it as something else. But if you import it as Edge Thing and you've already got an Edge Thing, it will just overwrite. So be very, very careful with that. So you just say from file, entity is good enough, and you select the file and you just browse to the file you want to get, which in this case is this one. I'm not going to do it because I already have Edge Thing created from last time. But once you do that, you will get this value, this Edge Thing operated here. So that will get you up to speed if you don't have it. Now let's quickly look at the things that we need to modify here to include in our, okay. So I need a few fields which I have to import from there. Now there are a couple of, you can see here that I've already got like all my fields, as you can see, S1, FV1 and all that. My failure is there. I had also created an info table for the history. You don't need to worry about that. We don't need that. Now, what I want to do here on this Edge Thing, I want to add a field. I'm going to first edit, of course. Before I edit, I can't do anything. I'm going to add two string fields, which are just directly going to be taken from the model. And you can just do that. There's one is called causal technique, right? And it has a default value, full range. Now, this will come directly from the model and fill in this value, so you don't need to worry about it. Okay, so I'm just going to add that. And I'm going to create a field, another string field called goal field, which has a default value, which is my field that I want for my goal, which is failure. So that is done. So I've added two string fields, and you can see that there, causal technique and goal field. I also need to add two fields which will receive the results of my score. So whether the predicted value of failure is false or true, and the score that it's actually been given. So I'm going to create two fields which are numeric. So result underscore failure will just be Boolean. Boolean. And I'm going to set it to persistent. Persistent means that if there are any changes, the values get saved across that. So if I restart my server, the value will still be persisted. So we won't lose it midway. So we need to do that. And then I'm going to add result underscore failure underscore MO, which is a number. Now this is my actual score from the model. Again, set it to persistent and we're good to go. So now my object has been modified adequately. If I just hit save. So this is going to be the values are on there, all the things that I need. Now I come back to analytics. I need to create an analysis event now. So I go to analysis event. Analysis events get triggered every time you can set analysis events to respond to data change. So what we're going to do is every time the value of one of the fields of edge thing changes, we trigger an analysis event that calculates the prediction on live data and then pushes it back and fills it into the edge thing. So let's do that. So let's create a new analysis event. An analysis event has to be mapped to a thing. So I'm going to specify edge thing here. Again, like everything, I get an autocomplete. The event that I want to handle is data change. So when a particular type of data change, you can see all the different types of, when, if there's any data change, if there's an alert that we're manually setting up, we've seen those in the past. Now, although there are like all the properties change at the same time, we're only going to flag it on the basis of S1 FB1, which is the first sensor, first frequency band. So when that changes, when the data in that changes, trigger an analysis event. Similarly, we take vibration AP and we take the model that we have done there. Everything else can just stay the same. Okay. By the way, just be careful when you see this listing. If you were here last time and you had the info table, it will be listed twice, S1 underscore FP1, because there is a property under the info table. Please select only the first one. Okay, that is the one that we'll be changing in the thing. So then let's just hit save. Our edge thing is created. Now we need to map the data types in there. So let's select the edge thing. It's not enabled yet. Let's go to map data. And then we just let's go to inputs mapping. Okay. In inputs mapping, we want to set a few different things here. So we've got the event here already. We want to look at the thing rather. So by the way, if you have the info table property, minimize that because we won't be using that. We need to map the analysis events info type here. So we've got S1 FP1. I want to map that to. So I'm going to select that and I'm going to map it to input data shape here, map 1. Similarly, S1 FP2, map that. So you can see the reading also changes. And we're going to map this. So this maps all the fields for our thing. Now we also need to map the causal technique. Oh, I think I missed out the last mapping, the last one. Let me just go back and map that. We need to map the goal field, which we set. Yeah, that should be fine. That's enough for the inputs mapping. Now let's go to results mapping. And we need to get the 2 output fields that we have here. So let's go to that. Let's select the thing. And we need to take the failure value and map it to our result failure property. And we take failure MP and we map that. What this tells it to do is to automatically update these values in the thing from the result of there. So you can see here, it is mapped over there. We don't need to map anything from the event source. So what this will do is it will take the result of our prediction and map it to these properties directly. So we can just say close now. So all our properties are properly mapped up. So we're ready to now enable our event. Okay. Now, once we've enabled the event, it will start running. Nothing will happen now because our values are not changing. Okay. So let's go back to edge thing also now. Now in edge thing right now, even if I save, I can't edit these values at all. So if I go and I try to say, I want to set this value to 162, it won't let me because it is actually a bound property, which is bound to an edge thing. So what I need to do is I'm going to temporarily, I'm just going to edit only S1 FP1, and I'm going to remove the binding for now. Okay. I'm going to remove that. Once I do this and I hit save, I can go, sorry, I'm in the wrong one. I can go here and set my value to say 162. I'm not going to change it too much. When I do this, you will notice my goal field gets filled up. Sorry, you will notice after if I refresh, that I get a result failure MO. So I get a score of 0.061, which is less than 0.5. So the Boolean is set to false. Now, if I come back to analytics and I look at that, you can uncheck filter completed data jobs. It gives you a list of this thing. It says this is the prediction that was made. So it says this is the prediction that was made. These were the results of the prediction. It gave a value of 0.061. And because we've already mapped it, it maps directly. Our edge thing is also updated. Now, if I go again and I edit this and I make it say any other value, 178, I hit refresh, you can see the result failure has changed again. Okay. Now, again, this is changing because I have set that up. What I'm going to do here, and this is where it becomes important, and there's no time to probably go over everything. I'm just going to show you. I'm going to assume that you've already set up the EMS. There are a few steps that you have for setting up the EMS, so you can see that. But I'm just going to set up my EMS here. And I'm going to actually, first thing that I have to do is I have to rebind S1, F1. So let's go to remotely bound. And the remote property is also S1, FP1. And I'm going to just use it to push type will be always pushed. So now it's bound again. I'm going to go back to my EMS. Remember, my EMS is all run from this folder called EMS. When I do this, I'm just going to run WSEMS here. I've already set all the connections and everything last time. So this will be initializing and it will be setting. And that means my EMS is started. And I have to set up another box called Lua script resource, again from the same directory. This is what is my process manager. So this is fine. Now, if I come back to my edge thing and I say save. Now, because I've started up the EMS, it says edge thing is calculated there. And if you go to the properties and alerts, now if you look at this, my values will be changing in real time. Every time I hit refresh, you will see. So you can see S1, FP1, S1, FP2 is changing. And every time it's changing, okay, right now it doesn't seem to be updating yet because there will be some lag. Let's go back to my analysis. So now you can see all the events taking place. Edge thing is still connected. Okay, so now it's changing a bit. For some reason, okay, there it goes. It's changing now properly. So you need to, there is a little bit of shuffle there. So you can see now that analytics is changing around. Like if you look at the jobs. Of course, this is a lot of overhead. So you want to be running this normally in a proper server. If I see the, so we've already done in a few minutes, we just run a few bits on that. Okay, this pretty much does everything. I'm just going to disable the event before it keeps on logging since we're already covered up with a few things. The last thing that I want to do, I just want to show you how to set up a quick mashup. And this is pretty much the last one that we're going to do this really fast. So a mashup is the web application that we create here. So I'm going to go over to Mashup Builder. We just call it like analysis mashup, right? Main thing we have to work on here is the design. So under design, in the interest of this thing, I'll just use a static mashup so that we don't bother with responsive to stuff. I'm going to add a few widgets here. In fact, I'm not even going to bother with label widgets or anything. I'm just going to show you the, let's just use text field widgets. I need 5 text field widgets, and I'm just going to copy all of these for each of the frequency readings. Okay, so we've got that. I'm also going to add an auto refresh because we wanted to refresh on the go. Okay, I want to add some data here. So I'm going to just get my thing from there, the edge thing. Sorry, wrong window. Edge thing here. So I get edge thing. I search for the get properties. Execute on load. Done. And I want to bind. So I want to get all of my data, each individual thing. So when I expand get properties, okay. So I'm just going to bind this. To bind, you just need to drop on that and just bind to text. Then you just bind here to the text. So each individual property, we're going to ignore S2, of course. And we finally got this one. So that's the text. Actually, we need two more text fields for our results as well. So let's just do that. One more text. We just add two more. And we will just bind what we want to look at. We want to look at, which fields are there? Result failure. I'm just going to bind it to text rather. Since it's a Boolean, I could actually bind it to like a checkbox or something, but just for the sake of quickness, I'll just bind it as a text object. Okay. Now I also need to set up. So the auto refresh is like sets up a timer. I want to make sure that just select the object and just click refresh interval. It's set up to 30 seconds at the moment. I'm going to set it up so that it sets, let's set it every 2 seconds. Yeah. So every 2 seconds it will refresh, but I need to bind get properties to the event. So I just take the function get properties. You can have a look at all the, I can also do it from here. So on refresh, I'm going to just drag it and drop it to get properties. Okay. So now you can see it bound here also. So every time refresh is called, get properties will be called. So I won't need to have to hit F5 or anything. So let's look at our mashup. Yeah. So there you can see the values and it's refreshing also. So it's giving a few different readings. I think it's got stuck again here. Oh no, because I have disabled my event. That's why I'm not going to be able to, but you can see the values are refreshing here from the edge. So I'm just going to switch this off for now. I'm going to go back to my analytics and make sure and enable my event so that it starts updating. So it started updating. Let's go back and let's start the refreshing again. Let's see if the analysis jobs are getting created. Okay, so it's waiting and it's got a status there. It's completed. Let's look at the values. Okay, it's changed. So now it's changing. Now you can see the values are changing based on what the input values are. So we've set up our full prediction loop here. We've operationalized our model, then it is getting data from the edge, and then it is updating here. So this pretty much completes everything. I had one last thing to show you. Let me just quickly do that. You can also control your mashup for, like there are the mashup, the analytics server also gives you an API. So you can control your function. So remember right now I have to go to analytics and I have to enable my enable and disable from there. I'm going to actually just add quickly add another button here that allows me to I'm going to just change the text on the button. I want to change the text here. So I'm going to change it, the label from button to disable, and this one to enable. I'm actually going to call it enable analysis and just put it to the next line. Okay, so I've just created 2 buttons. What I need to do is I'm gonna get data from, and you should select resources here because all the APIs are there. You can actually select analysis services there. And I want to actually select the event management services API. So you can see a lot of different things there. And the category that I want to get is query analysis event. I'm only going to execute that on load. This will give me the ID of the event. And I'm also going to do enable analysis event, which I will link up to my button. And I won't execute those on load because those are related to buttons. So let me just actually bind these things. So enable analysis on click, I want to make it run the enable analysis, and disable analysis on click, I want it to run disable analysis. But at the same time, I need to pass a parameter, which is the event ID. The event ID will come to me from this query. So I need to go to the return data, and I need to, sorry, not in this. I need to go to return data, all data, and take the key and bind it to the event ID for my 2 functions, right? So similarly, I need to do that for, I need to take this, the key ID. Oh, I can't see the, okay, let me just drop it. I'm going to do it the other way around. I'm going to expand this. I need to take the parameters. Disable analysis event is tied to the key, and enabled analysis event. Okay, the event ID is not tied. So I need to take, not this, from query analysis event. I need to get the return data, get all data, take the key ID, and bind it also to this event ID. By doing this, I've made sure that like when you enable, disable, it is binding only that. We only have one, but you can have multiple ones like that. So we just save, let's refresh our mashup. Let's disable analysis. So it'll stop the analysis from there now. So let's look at our analysis jobs. So right now it's disabled, so nothing is increasing. But if we go to our mashup, let's go to enable analysis. And there you can see it's starting to work with the data. So where you can even use the API from here. Thank you all for attending the session. I know we had like a few hiccups there, but you would have seen that this is quite a powerful way of handling things, and it's all built into the cloud platform itself. So you don't really have to do any installation. You don't have to write any code. You can operationalize your model in just a few steps. I will record a shorter version of this so that I can convey all the steps to you. So don't worry about that. But thank you all for attending, and we'll definitely see you in the new year.